Hi, welcome to another episode of PX and the Art of Programming. In this episode, I will make a summary of everything that I have discussed so far, and I will have a look together with you guys into the concept px2index. But first I want to start with a comment I received by a user, and his name is Dacian88. And he has a sense of humor. I like that. And his phrase, you can read it with me. Somehow you managed to make C++ look even more confusing. Somehow. I can understand what he means. That is the reason why I will hold a summary of what I have talked about so far. First of all, let me get back to the project. This is a project set up in C++ and using Xcode, Apple's Integrated Development Environment, IDE. I will launch it at level 4. Being a summary, level 0 is the most simple level. And level 1 is a bit more complicated, and so weiter. And level 4 has implementations for a thing called sockets. And I have written on this level a simple structure, a simple struct, and it is a console, a terminal console. And I will run it at level 4, as you can see. We do some compiling. I will have a sip of tea, waiting for Xcode to finish the compiling. Just be patient. Rule number 1, if you want to write flawless software, perfect software, take your time. Right, it is running. I will start with the terminal session. Make it a big. Whoopsie-daisy. Something isn't working. Oh, let me check this. What is it doing? Oh, I'm so sorry. It is busy running the startup. I will go into this later. This is extremely complicated software. PX itself produces a makefile. So you can compile it using the GNU make function. And it's now setting up the make files because I have incremented the version number for from 19, standing for the year 2019, 8, standing for the month, August, and it was 1, and I made it into a 2. It's the second version this month. And PX has detected that, and at level 3 it will start making, and then it will make new makefiles. It is now busy making the makefile for the top level, and it's level 7. And it will take some time. Let's have a look at the makefile at a somewhat lower level. This is the resource directory. This is the directory for the GNU. This is the directory for Xcode. This is the directory for GNU, px0, and this is the make file. If I double click it, I don't know what will happen, so I will ask to open it, use a text editor, why not? Yeah. This is the make file made by px itself. Here it states in the command line that it will create the px0. This is the version number. These are the flags. This is a standard make file. I use the nomenclature of make itself. Well, let's not discuss the whole structure of this make file, but it's quite simple. It will compile. This is the first file to compile, px0.cp. That will be, the target is the px0.object, and px0atomic.cpp is then compiled into pxatomic.o. Then a simple file structure, so over here, px0file.cp. I will make a different episode solely on the 0 level, so the most uncomplicated level. And of course the big thing is over here, where px0 is created. Is this the line? I haven't read this for a long time. I think it is. This should create the px0 file. Yes, it should. I think. Yeah. Doubty. I will make a different episode on this. And well, it's now finished. It has created the level 7 make file, and just for fun, let's open this make file. Oop. It refuses to open. What's that? Just bear with me. XGNU. This is the make file. And this is quite a large file. As you can see, it has the make file has 56,000 lines. Yeah, you heard this right. 56,000 lines. That's quite some makefile, don't you think? It's produced automatically by px itself. So is this a simple piece of work? No, it is not. It's quite complicated. And now it is running. And now I should be able to connect to the terminal. Yep, we're in. This is the terminal. The console, and the console starts with the phrase "Hello World," like being a real C program. Here it states the version number, version info. The version number is 19.8.2, and this is some info about the version itself. It's a debug version, meaning the debug macros are active. It is not optimized, code optimization is switched to off. It would make debugging quite annoying. And the server is a development server, meaning special stuff. It is not a server to be used by the end users. Passwords, for instance, are ignored, are not needed. You can log in on any account on this server. It's only useful for development and testing. Right, in this console, we can type in an expression. 2 plus 6, for instance, is an expression, and it will evaluate the expression and give the answer. That's it. Oh, this is simple, don't you think? And this is only the beginning of a very big thing. What is also working are functions. For instance, this is an expression, and this is my first name. Quote, Perry, quote, is an expression. And the evaluation of this expression is my first name, Perry. Are you with me? It's quite simple. Now I will type a function, len, Perry. And the outcome is 5, because Perry, the string Perry, has 5 characters. I have also incorporated the function select in a very primary phase, I must add. Let me look up the name of the function. Bear with me. It should be over here. And where is the name? This is the one. I was looking for. I can type it from here. I know it already. Just for testing. It is a work in progress. Well, this expression asks for the data of a table. And the table is named by the primary key of the table. There will be an episode only about the subject of primary keys and normal fields. Primary keys, secondary keys, foreign keys, and normal fields. Coming to think of it, there are some books that I would advise you to read, to study, when you want to know more about the background of this project. This is a project that I started in 1988, which is about 30 years ago. And the title of the book that I will include in the description box is not only Literate Programming of Donald Knath, but also the two books written by C.J. Date, and they're about databases. Database design, database structures, database programming on databases. More about that later. It's all about databases, because PX is the perfect language. The aim is to be the perfect language to address databases. Better than SQL, which is not perfect. This is perfect. So if I type select the table PX passwords, it's an acronym. PX is the letters of Project X, passwords _ underscore primary key. That's the name of the table. And then it will give a table with all the passwords. And the passwords are encrypted, as you can see here. And this is only the beginning of the encrypted information, and the rest I just trunked and chopped it off. This is only as a demo of a simple table. And if I type in a typo, a syntax error, for instance, Perry without quotes is syntactically incorrect. And the system will respond with identifier not found. Starting with the P of Perry. If I type in 1 plus 6 parenthesis 100 minus Perry, then it will say some data could not be read starting at, and then the first parenthesis, that's where it went wrong, 100 minus Perry. But now I will type in a syntactically correct phrase which is semantically wrong. That's this phrase. Here 70 is divided by 7 minus 7. And now we will get a different ball game, because a semantically incorrect expression has a history. Well, this is the history of a syntactically incorrect phrase. And it will inform you that the problem is within the parentheses. And here it will give the complete story. And as you can see, the output of the semantic, the problem with the semantics of this expression, the output that the system gives is again a table, like here. And it is indeed the same software on the background that produces this table. Let it work, let it sink into your thinking. We are not talking about SQL databases at this level. They will follow. Of course they will follow. But this is the first level where we encounter tables. Okay? So. And we have a long way to go. And now I'm wondering, if I type in 100 minus Perry, what it will say. There it says identifier not found, and now it denotes correctly to the P. And here I am not satisfied with this output. And where did this go wrong? Let me have a look at the code. This looks okay. Syntax error info. Let me have a look at this function. Yeah, it should recurse through the lines. What I was expecting is if I type this phrase 1 plus 6 parentheses left 100 minus Perry, I expect 2 lines of syntax info. One line with this info, identifier not found at, and one line with some data could not be read starting at. I will look into it after this podcast. It's a work in progress. A thing that you can learn from this is that it is very important that the system, px in this case, gives very detailed information about situations that are not correct. You get? Because you have to inform the programmer what exactly went wrong. To the maximum way, in a maximum way. For instance, I am quite satisfied with this output. 7 minus 7 equals 0. 7 minus 7 in between parentheses equals 0. That's okay. But 70 divided by 7 minus 7 in between parentheses is not okay. And there the error starts. You get? In a real life situation where a programmer has to debug a complicated expression, because expressions will become very complex in the end product. Then a programmer has to know at a minute detail where things went wrong. Okay, now back to the remark that the end user made about the software being somehow I managed to make C++ look even more complicated. Let's have a look at px2index as an example of the software, of how the software looks. px_index. The meaning of this structure is to store objects, especially objects, under a tag. And a tag is a meaningful string, a name. It is especially meant for retrieving the objects concerning a field. Like for instance, this is a field, and it has an object connected to it, and I want to be able to locate the object pxe valuation information underscore error using this string. Well, and how does px2index work? Well, it has to be an object itself. And the type is a px2 object. It's I won't go into the content of px2 object, but it's just an object. A meaningless, colorless object. And the add function adds the address of an object under a tag. For this moment, ignore pxn the number, just for this moment. And the other thing is that I can use the method find to find the object under a tag. And how is this done extremely fast? It's a question for you. Now, what you could do is that you sort the list of all the objects and you sort the objects in an alphabetic order on the tag. And you just test the center of the list. It's called a binary search. So. And if it's too high, then you just test on a quarter of the list. And if that is also too high, you test on an eighth part of the list. And in so many steps, you will get into the right object. Huh? But this will take some computing time. That is not preferable. Then you may say, well, you can set up a hash table. But when you use a hash table, you might get into something as called a collision. That two strings, two tags, will come up with the same hashing value. And then you'll have the same problem all over again. And to calculate the hashing value, then this will take computing time. So I've been thinking on this problem, about this problem, how to solve it. And I came up with this. I'm still working on it. I already have found some improvements. So maybe in the next episode I will start again on the function, or the structure px2index and the function add, the improved version. And now let's have a look at the method, the implementation of the method add. And its meaning is to add the address of an object, the object, it's called the object, under the tag. First of all, this is a summary also. Huh? It's about the nomenclature, the giving of names. Parameters are named the tag, the number, the object. Local variables are named my. You have to learn these. You have to learn the way that the variables, parameters are named to make it easier for you to read the code. Now, what happens here? Here an array is declared with a series of indexes. And this array has a length of the maximum length of a tag plus 1. And the maximum tag len is, can I look this up? Yep. Here it is. 256. So the maximum name of a variable is 256 characters. Well, that should be enough for now. Huh? Because that is the notion behind this function is that random access memory is not a problem. I have not delved into that truth, but when you write software, when you design software, you assume that the amount of random access memory, the size of your hard disk, the whatever, it's all unlimited. Don't program with in the back of your head, well, there might be not enough random access memory. Oh, don't do it. Just assume that there is unlimited amounts of RAM, random access memory, and don't overdo it. So a variable length of 256, that should be enough. Now, what happens is that this array is filled by this function. And the function has as first parameter the tag, meaning the parameter that the add function was called with. The tag is handed over to index values from tag. The address of my indexes is given, and this variable that I at this moment don't know the true meaning of it. I know it already, yeah. The tag is cleaned, but we will get that story when we look at this function. This has nothing to do with C++. It has to do with perfect programming. Because if we look at the function add, the only thing that happens here is that the tag is converted into a list of index values, and then another function add is called, which will add the object with the list of the index values. And the tag is not handed over to this function. And you should ignore the number for now. I think I will remove the number, namely, for now. Yeah? Now, what happens in px2 index values from tag? I think I can find this function. Yes, it's over here. Let me have a look. Yes, this is the one. What it does, it scans as fast as possible through the sequence of characters denoted by the tag. And here I am missing some debugging statements. Just look as I type along. It's for you to understand how programming in PX is done. So under debug, we check PX OK always, that the tag, this pointer, has a value, and that it doesn't denote to a 0 value. It doesn't denote to null or nil. And that px OK number pointer, that's the n, this pointer denotes to a empty spot of memory. So the contents of the len equals 0, because we're going to fill it. we have a read pointer and a write pointer. And the write, the pointer to write to, is the array. Let's get back to the add function. Index values from tag. The first one is the pointer to the C string, the tag. And the second parameter is the locally defined array of bytes. pxb, short for px byte. And it will ask the length of the tag after it's been processed. Back to this function. Like here we can see that spaces are ignored. So they are not part of the tag. Here is the first one. If we have a lowercase character, then the index value equals 10 plus the value of the character minus lowercase a. If we have a digit, then the value for the index is simply the value of the character minus the character value for 0. And if we have an uppercase character, then we'll do the same thing as we do with the lowercase, namely 10 plus the value of C minus capital A. And all the other characters are written as value 36. Just by definition. This software, you might say that this is a kind of a hashing function. Don't you agree? Huh? This, I see a thing for improvement. We assume that the string, the tag, does not contain any control characters. An A to Z in lowercase and uppercase is converted to a simple to a numeric value, just as the digits. And the order in which this is done, most of the time, the tags will be a lowercase phrase. So that is the first thing that we check. Is the character, which is read, the content of my pointer read is a character C. If the character C has no value, it's a null, then we break out of this loop. We increment the pointer read for the next step, and then we start. If C equals a space, let's just continue. So we ignore all the leading spaces. And then the first thing that we ask ourselves is the character more higher or equal, more or equal than the lowercase a? That's the first thing. Digits are the next thing that we check, numbers. And uppercase, well, most of the variables are written in lowercase, so we check this as number 3. This is a very fast way of hashing. Don't you agree? And after this, there is an array which will hold numbers. And this array with the numbers varying from 0 to 36, so 37 different indexes, tell a story about the location of the object. So the hashing, first of all, if this hashing function has a collision, then there is something wrong with the naming of your variables. By definition, a variable with only a lowercase a will collide with a variable only having the uppercase a. But this should be a problem. It is ridiculous to have two variables and one variable is a lowercase a and the other variable is uppercase a. There is no way of naming your variables, naming your fields, naming your parameters, whatever. And I am at this moment still a bit doubty about the fact of this functionality, that all other characters are seen as a single value of 36. Meaning that a variable just a second, yeah. Make a big font a bit bigger. This variable dot a, lowercase a, for instance, will have the same hashing function, hashing value, as this variable. Both they will be the number 36, and then the first character, the first character, the dot and the $sign will both produce number 36, and A will produce the value 10. These two variables will both have the hashing code 36, 10. So two values. Is this correct? I'm not quite sure whether this is correct. Maybe I should allow for different namings like hash A and $A. Maybe this should be allowed. I'm not quite sure yet. But on the other hand, this is of no problem at all, because the hashing function, what is it? It's starting at line 9, and we end at line number 50. So it's 40 lines of code, including some debugging lines. 4 lines debugging code, and here we have 4 lines, 8 lines debugging code, and here we have 5 lines, 6 lines debugging code. So in total we are talking about 30 lines, 40 lines of code. That's virtually nothing. And this is easy to extend. There's no problem at all. And if we look at the code itself, what it's all about, it's not that you learn in an hour how the index works in detail. I will try to discuss it as much as possible, but let us focus now just on the programming style. Well, first of all, the debugging code here will see to it that if this function is called with things that you do not want, for instance, a string with control characters, then this statement will detect it, and it will break in such a way that your log file will contain the names of the source code file, the multiple files, a complete chain or trace of all the functions that led to entering this piece of firing, this piece of debugging code. If this is not true, then you will see an error in your log file, and with all the calling, all the names of all the calling functions. And secondly, here we can see that this is my pointer read, my pointer write to the result, the character C, and this is the for loop that I use in cases where I want an infinite for loop. There are only two loop structures used in PX, namely this one, for infinity. This is correct C, and we will break out of the loop using the break. And yeah, that's the only break that I see. And then the len, of course, the parameter the len. So here you can recognize it. This is a parameter. The content of this pointer is made equal to the pointer right minus the beginning where it started to write to. And this is a debugging statement. And I much more prefer nowadays. This macro means px OK under debug mode. And I will change this in px OK always. And I will use the debug macro. I find this a bit more informative. The content of the len should be less than the maximum length of a tag. Don't you agree? Okay, still with me? And then the function returns px_ok if everything goes fine, of course. If this macro fails, it won't return px_ok, it will return px_ko. And this will fire up the error logging stuff. But now what happens if the calculation of the index values went okay? And now we want to have the object. Now, we start with a bit of a debugging code. Just to be sure that everything that you hand over to this function is checked before we start doing anything. And let's see how many lines we have. We start at line number 414. And we end at line 496. So it's about, say, 80 lines of code, of which these are 20 lines of debugging code. About. And here we have debugging code. So if we strip out the debugging code, it will be 40 lines of code. Let me get this out of the way. Sorry. I am starting to learn Hebrew. I'm sorry for this. It reminds me every day that, hey, you should take up your Hebrew. Well, you are learning PX. I'm learning Hebrew. Now, how do we do this? How do we store an object? After we have checked the parameters, the incoming parameters, then we call a, and here it's going to a recurse. And where is the recurse? It should be over here. The thing is that every index has, the index has an array. And the array contains the addresses of subarrays. And the subarrays contain addresses of subarrays. So it uses a lot of random access memory to store an object. But random access memory is of no issue. I have, not so long ago, I found on the internet a refurbished machine, a Compaq machine, from the firm Compaq, and it had 256 gigabytes of RAM. Refurbished. It had about 8 processors, but 256 gigabytes of RAM. And the price of this machine was $8,000. So don't tell me that random access memory could be a problem. If you can buy a server of $8,000 with 256 gigabytes of RAM. And where is the recurse? This is the adding. Maybe I should look into that. There is a recurse. I know it. Or else the code wouldn't be so short. It's here. Of course it's here. Yeah, this is the trick. Can you find the recurse? It's right under your nose. It's all about this. We have the address of the array with the arrays. And a single array can have an object. So you have to picture it. And we step the address, the first address that we take is the main array. And after one loop, because we have to go through all the index count. We have to go through the whole length of the tag, the clean tag. So a tag of, say, 5 characters will step 5 times through this loop. Still with me? The array that we work with is the array that we worked with, and of that array, it's subs and then my index. And my index is retrieved from the index values number I. Now maybe you should lean back in your chair and see that this is perfect code. It's extremely perfect. Extremely simple, extremely fast. And here we retrieve the array to store our object. And the object is stored in a bit complicated way, and this is what I'm going to change. So. And this variable has got to go. This, however, this will stay. The count, its nomenclature, the way that variables and parameters are named, its means that this variable count belongs to the structure px2index. Well, the index is a hierarchy of arrays, and itself has a variable holding the number of objects stored in the index. Now we're about, I'm out of time. And in the next episode I will talk about retrieving an object from the index, and I will have modified the code. Because there's when I designed this a couple of years ago, maybe 10 years ago, something to think about. This code I have written more than 10 years ago. Yeah, more than 10 years ago. And I can get into the meaning of the code while I am talking to you. You prove that to me that you can do it with code that you have written more than 10 years ago. So I have just proven to you that if you stick to this paradigm of coding, you as a programmer are able to explain the working of your code that you have written many, many years ago instantly. I am quite confident that I have written this code, say about, I was still married. I was still married, so, and I have divorced the mother of my child about 10 years ago. So this code must be written in 2006. Oh, 13 years ago. Oh, 13 years ago. Maybe 14, 15 years ago. And I am going to modify, going to streamline it, because in those days I thought I made it too lovely. That's another rule of writing perfect software. Do not make your software too lovely. Do not make it too complicated. And I broke one of my own rules. But that's how things go in life. And now I can see that px2index has too much functionality. And I will take it, I will make it, I will remove some functionality. And therefore removing lines of code, I will make it more slimmer. Well, I hope this was informative. And getting back to the remark that I got, somehow you managed to make C++ look even more confusing. Well, there is a reason for it. Because you're not looking just at C++. You are looking at a way of writing perfect code. Code that you can modify after not having looked at it in more than 10 years. Imagine what this can mean for you as a programmer. You can build up a code base over years and years and years, and you can modify the code that you have written 20 years ago. And now we are talking about code reusability. Because any programmer can get into a phase in which you will see with your mind's eye that you have written a piece of code many, many years ago, which you can write much simpler. And do you have the guts and the means to rewrite old code without the need to worry that you mess things up? And if you don't fully understand what you have written many, many years ago, then chances are that you will mess up. You get? And don't mess up. It's another rule. Never mess up. Hey, thank you very much for listening. And I am afraid that you will spend lots of time before you can fully understand what the project PX is all about. Just as I will have to spend many hours before I can read Genesis 1, verse 1 in Hebrew, which is my goal. Bereshit. Bereshit? No. I know it starts with Bereshit. So I will start working on my Hebrew today, and I hope that you will get into the older episodes of PX and watch them again. This is what I have to do to learn Hebrew. It is repeat it, repeat it, repeat it, repeat it. Again, again, again. Just as long as it takes me, as it will take me, to read Hebrew from right to left, to know about the Aleph and the Bet and the Gimel and the Vav and the Yod and what's the other one? The love. Man, I should go to my Hebrew lessons. Thank you very much for listening to me. And I will speak to you again about PX and the art of programming in the next episode.